If your AI agent is chewing through raw HTML, you are paying twice, once for crawl infrastructure and again for tokens your model should never see. WaterCrawl promises a friendlier answer. Give it a URL, choose crawl, search, or sitemap, and get structured web data that is easier to use in an LLM workflow. I ran the public tools, launched the self-hosted stack, read the pricing, privacy policy, source, and license. The pitch works. The catch is deciding whether the full-stack convenience is worth a heavier setup and a commercial restriction hiding behind the open-source label. WaterCrawl is not just a Python scraping package. It is a web application with a dashboard, REST API, client SDKs, live progress events, exports, team features, and integrations for tools like N8N, Diffie, and MCP. The workflow is simple on the surface. A crawl request controls depth, page limits, domains, paths, rendering, selectors, and whether you keep HTML, links, or only the main content. Underneath, WaterCrawl schedules the work, renders pages when needed, stores results, and exposes progress through server-sent events. That makes it closer to a self-hosted crawling platform than a single library. The first proof is deliberately boring. I used WaterCrawl's public playground to crawl example.com. The request moved into processing, completed, and returned one page with the example domain result. That proves the public path can accept a URL, run a crawl, and return extracted content. It does not prove anti-bot reliability, throughput, or perfect extraction across messy sites. Still, this matters because the source post only showed a GitHub screenshot. The moving capture is the first real evidence that the basic request-to-result loop works. The second case uses a different mode. I switched to Sitemap and pointed it at WaterCrawl's own public site. The run completed with 52 URLs, including pricing, contact, terms, privacy, ecosystem, blog, jobs, and changelog pages. This is not another angle on the same single-page scrape. It is a discovery workflow for mapping a site's reachable structure before a deeper crawl. Again, it is a controlled test on the vendor's own site, not a benchmark. But it clearly proves a separate use case and a distinct output. The self-host story is both WaterCrawl's strength and its first cost. Official docs ask for Docker Engine 24 or newer, Compose 2 or newer, at least 2 GB of memory, and 10 GB of free disk. The Compose stack brings up Django, ScrapePy workers through Celery, Redis, PostgreSQL, MinIO, Playwright, Jinx, the front end, and MCP support. In my run, 9 services started, the database reported healthy, and the local interface returned HTTP 200 before opening the administrator setup form. The first pull failed because this Max Docker credential helper could not access the keychain from a non-interactive session. An isolated Docker client configuration fixed that machine-specific blocker. I did not create the administrator account or run a local crawl, so the honest result is setup reached, not full local workflow completed. This is self-hostable, but it is not zero-ops. The appeal is breadth. WaterCrawl documents crawl depth and path controls, JavaScript rendering, CSS selector-based extraction, HTML, and link options, screenshots or PDF attachments, live progress, webhooks, search, sitemap generation, and downloads. Official SDKs cover Python, Node, Go, and PHP, while Rust is still listed as coming soon. This package makes the most sense for an AI team that wants a visual control plane and an API in one box. It is less compelling for a solo developer who only needs a lightweight crawler inside one Python process, or for a team that already has storage, queues, workers, and monitoring solved elsewhere. The cloud path is easy to sample. As of August 27th, the free plan advertises 1,000 page credits per month, 100 per day, 1 concurrent crawl, depth 2, and up to 50 pages per crawl. The startup plan displays €4.80 per month on yearly billing with 120,000 annual credits. Growth displays €9.80 per month with 360,000 annual credits. The site marks those prices as limited offers, so check the live page before budgeting. Retention rises from 7 days on free to 30 on startup and 90 on growth. The public playground also worked without creating an account for these two tests. Now the part that should affect a real buying or build decision. The README calls WaterCrawl open source, but the repository license is not plain MIT. It adds a restriction that says you may not use the software to run a service similar to WaterCrawl or another commercial service without explicit permission. GitHub therefore reports no recognized license identifier. For personal tools, internal systems, and many self-hosted workflows, that may be acceptable. For a startup building a competing hosted crawler, it is a stop and read the license moment. The cloud privacy policy also says WaterCrawl collects account information, usage data, and crawling configurations, uses analytics and hosting providers, and retains information while an account is active or as needed to provide the service. Cloud plans separately advertise result retention windows. Self-hosting gives you more data control, but it also gives you the work of securing credentials, storage, endpoints, backups, and updates. Compared with Firecrawl, WaterCrawl is much smaller, but the product shape is familiar. Hosted crawl APIs, a free tier, structured outputs, and self-hosting. Firecrawl's repository is HPL 3.0 and its ecosystem is dramatically larger. Compared with Crawl4AI, WaterCrawl offers more of an integrated dashboard and service stack, while Crawl4AI is an Apache 2.0 Python-first project that is easier to treat like a library. There was no head-to-head speed or extraction benchmark here, so I would not call a universal winner. Choose Firecrawl for the most mature hosted ecosystem, Crawl4AI for permissive Python-first control, and WaterCrawl when the dashboard, API, and self-host package are the actual feature you want. My verdict is positive, with a boundary. WaterCrawl's public crawl and sitemap workflows worked, the self-host stack launched, the SDK and integration story is broad, and the free tier is generous enough for a real evaluation. It is worth trying if you want a visual crawler your team can inspect and operate. It is not my default recommendation if you need the simplest Python dependency, a permissive license for commercial reuse, or proven production scale performance. Start with the public playground. If the workflow fits, read the license, run the compose stack in a disposable environment, and test it against the exact sites your product depends on before committing production data.